Chapter 8D, Factorizing Difference of Perfect Squares. So we're using a formula, but this formula is something that you need to consciously recall to your mind. We talked about what is the difference of perfect squares. So instead of having a plus b squared or a minus b squared, we multiply a plus b with a minus b. And therefore, if we expand it, you know that the cross term minus ab and plus ab can be cancelled out. So we only have a squared minus b squared left. Okay, that's the formula. Now, if we can go forward, we know that it can be reversible. Therefore, we can factorize it back to its original term. Now, an example is if I write x squared take away 4 squared, then we can easily go back using the formula x plus 4 and x minus 4. Now, but what we need to pay attention to is that sometimes the number, especially the number, does not necessarily appear in a perfect square form. Okay? But we should know that 4 is 2 squared. So if we write it like that, x squared take away 2 squared, then now our a is x and b is 2. So as a result, we can factorize it back into x minus 2 multiplied by x plus 2. You can reverse the order that you write plus or minus, but you should know that it's x and 2 either plus or minus. Okay? So the key is to identify for each of the term what actually makes up the perfect square, or if you can see this is a perfect square number. Okay? Therefore, if you are familiar with those perfect square numbers, for example, 4, 9, 16, 25, or 36, then it will help you a lot. Let's see the second example. 2b squared take away 32. You notice that for these two terms, as compared to the first example, x squared and 4, they don't appear to have a common factor. But what we notice is that 4 is 2 squared, therefore we use DOPS to actually factorize it. Okay? So when we use DOPS, sometimes, for most cases, we shouldn't see a common factor. But for these two terms, there is a common factor of 2. So what we need to do is that if we need to factor the common factor out, and then we can see if we can use DOPS. Okay? So in this case, when we factorize 2 out, whatever has been left in the bracket is b squared take away 16. They don't seem to have a common factor anymore, but we know that b is squared and 16 is 4 squared. So we can factorize this bracket into b minus 4 and b plus 4 using DOPS. Last example, x plus 1 squared take away 4. Again, although this is a binomial, but it's still squared, so we see it as one term. So that's our a squared, and we know that 4 is actually 2 squared. So when we write it this way, our a, the first term, is x plus 1. The second term is 2. So it becomes x plus 1 take away 2, x plus 1 plus 2. So when we already have a small bracket, we still want to make sure that using DOPS, we are making these two terms into the multiplication of two terms. Okay? Therefore, we introduced the square bracket in this step. Okay? And then inside the square bracket, we notice that x plus 1 take away 2 can be calculated, and so does the second bracket, right? So as a result, we should simplify it before we leave it. Okay? So the perfect squares is these two, and we factorize sometimes if we have a slightly more complicated expression, like a binomial with a number, then we need to use a square bracket in the middle. And then when we simplify it, the square bracket disappears and we use the round bracket. Okay?